Yes.
Do you need drafting paper for the?
I don't. I'll say this. I don't. You can plot it out by hand. I don't mandate that it needs to be on
I mean,
graph.
it says write an equation for each line, then graph the line.
You can graph it out by hand. Next time, when I did the answer key for it out, you need to know how to do them. I'm going to look to see, is there a line on there? Is it labeled right? Stuff like that. I'm not going to go through and, which is, oh, the slope is not exactly true. Okay. Now, and by the way, who noticed what changed today? What's different about your environment today as opposed to what it was yesterday when you walked in? And what shape are those? What shape did we try to make it? What kind of graph is that going to be? Linear. You boys over on the side, it's probably nice not to be stuck tennis balls over the seat. Unfortunately, I think you're stuck still dodging them on the other end of the line. Does that line, as I look at it right now, going from my left to my right, does that line have a positive slope or a negative slope? Positive. There you go. And before you get all critical and start going, well, it's not exactly a line like this. Somebody said that. They're going, well, you look, it's not really a line because over on the right-hand side there, seriously? You think that I've got enough time for that? You're more than welcome to give it a go on your own. That took an hour. And I'm going to have to do it every time we go through and switch what we're working on. So you're going to see log graphs up there. Wonderful. Wonderful. Now, let's bounce over to what we were talking about for our notes for today. We're going to start off with what a linear function. And a linear function is any function whose graph is a straight line. Now, it can be an x equals or y equals equation, but what you don't have, you have a constant rate of change. Linear functions, maybe we'll get that down. That's a good thing to know going forward. Linear functions have a constant rate of change. What this means mathematically is that when you go through and you graph this out, or you're looking at an equation, there's not going to be any exponents other than ones. Some examples of a linear function would be, let's say, y equals x. It could be y equals, let's say, 3 minus 2x. That's a linear function. It could be f of x, which is the same as y equals 3 minus 2x. All of those are linear. Things that aren't linear would be something like y is equal to 2 raised to the x power. It could be something like y, oh, here's a good one. People always screw this up. Y squared is equal to x. Does anybody know what a y squared equals x would look like if you graphed it out? Well, if we have a squared there, what type, if it was y equals x squared, what type of graph would it be? What shape would the graph have? Yeah, it's a parabola. So instead of it opening up or down, a y squared parabola is going to open to the left or to the right. We do those this year. These also are not, this one here would not be a function. I think you did you do a vertical line test in Algebra 1 at all? Yes or no? Okay, so is a y squared parabola, one that opens to the left or to the right, is that going to be a function? Why do you say no? Perfect. Vertical line test, it fails. Okay, so bounce over to the other page. Here's some linear functions, and here's some that aren't. As you go over, all of the ones on the left are linear. Notice that when I go up by a constant x, the rate of change is the same as I go up by 2, and this well, I guess we won't touch that piece yet. You're going up by the same ratio. The change in the y over the change in the x is constant on the linear functions. Over here, this would be a quad if we graphed it out, quadratic. This is exponential. Notice as I go from term to term, notice here my rate of change in the terms is 1. But notice what's happening in the function values. Here I go up by 4, here I go up by 6, here I go up by 8. Now, by the way, what would be the next point that would be on this graph? Hands up if you can continue this nonlinear relationship out. 6 what? Yeah. Which that would be? 34, yep. Because you'd have to go up by 10. Over here, this is not going to be linear. I went up by 5 here, I went up by 10 here, and I went up by 20 here. That's called exponential growth. When each time you're successive as you go forward, it's getting multiplied by a constant value. So to go from term to term to term, I keep multiplying by 2. So the gap between the terms is going to get even bigger. Now, there's two different ways that you can go through and get a line. And the stuff that you need to know is there's two different forms. The first one up is called slope-intercept form. And you use slope-intercept form, or that form is the expected one, when you're given a line, when you're asked to generate the equation line and you're given the slope and the intercept, the y-axis intercept. Now, the equation, and this is what I love, you all have this, like, you yell this out and you go, what's the equation line? Y equals mx plus b. What's the formula for slope? Y equals mx plus b. We yell it out for everything. Most people don't know what it is. Here's the equation of the line. Looking at this, the m represents your slope. The b value represents your y-intercept as a number value. It could be given out as a coordinate as well, and it would be 0, b. Now, we have some issues. I have some issues with how they go through and show you slope before. Delta y over delta x. There's other ways that you can learn it. You can learn slope as m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you're looking at it graphically and counting, this is my other favorite thing. They don't tell you the actual way that this should work. It's not rise over run, it's rise over right. Because if you tell a little child to run, they're going to run in 1,000 different directions. If we tell you a direction, you'll know whether or not the slope of the graph is positive or negative, and that's something that people screw up all the time. We'll get to some like that. The other piece, and I don't know if you've done this form before, is point-slope form. Now, you use slope-intercept form when you've got the slope and the y-intercept. You use point-slope form when you know the slope and one point on the graph. And that looks like this. It's y minus y1 is equal to m, which is the slope, times the quantity x minus x1. You need to understand that x1, y1 is just a point on the graph. And m is still the same slope that we referenced before. The change in y over the change in x. Questions on that? You're going to need to know when you can use these different formulas. Sometimes you're going to use slope-intercept. Sometimes you're going to use point-slope. They're going to give you the same thing. All of these are going to give you the exact same line. All of these equations will be the exact same line. If I were to give this given line out in y equals mx plus b form, the first thing that I'd hope that you'd see is I've got to go over to the graph and determine what the slope is. Now, to figure out the slope, I always start at a low point and work to a high one. So let's say I start off with this point here, and I'll count to that one. Doesn't matter which one you do. Slope, as we said before, if you're given a graph, is rise over right. I'm going to start at the lower value and count how I get over this. So I rise 2 units. My right is 4 units, except something that I just said was wrong. My rise is 2 units, that's right. What's wrong? Yeah, because if we place a name on it, an orientation, you know when it would be negative then. If right is positive, then left is negative. So this would be negative, or 2 over negative 4, which is negative half. And then we can look at the graph and determine what our b value is, or our y-intercept, because you know that it's going to cross at the point 0, 5. So you know what your y-intercept is. Now, these 3 manipulations of the other equation give you something that's congruent or equal or the same line as that y equals mx plus b1. It's going to be y equals. And by the way, notice when we do this. This right here is telling me that the slope of the graph is negative a half. The x-coordinate of the point is negative 2. The y-coordinate is 6. It's always the opposite of the ordered pair if you need to, because it's y minus those values. So this is opposite what the ordered pair is in both cases. And you can use either the point negative 2, 6, positive 2, 4, or 4, 3. Questions on those? Here's another one that gets, I don't know, I'm so biased, I think the way I do everything is amazing. When we do this out, you all, again, in 13 years, very few kids off the top of their head are able to know whether y equals or x equals lines are the ones that go up and down or side to side. After you see this, it'll be very easy for you to remember. If you see a line going side to side, you're wondering what the equation of it is, because this is a constant line, it's going to have no slope. There's vertical and horizontal lines that have that are essentially straight lines. When we do this out, you have this horizontal line. Is this an x equals or y equals? Easiest way to remember is if you start writing it, your y's that way, you'll be able to recognize instantaneously that y equals ones are the ones that go side to side. How do you figure out the x equals line? Well, again, if you write it out like this, the x shows itself as the one to go up and down. The y is going to be the one that goes side to side. So looking at this, and you can look at it as a collection of points. So this could be, let's say, the point 1, 1, 5. It could also have the point, let's say, over here, it might be 5, 5. Over here, it would be the point, let's say, 13, 5. If all those points are on the same line, you know what the equation of the line is going to be. It doesn't matter what the x is, the y is always equal to 5. So in this case, it's always y is equal to some number. If the line is flat, does anybody recall what its slope is going to be, what the value of the slope would be? When we talked about it before, we said it's rise over right. So how much are you rising? None. And how much are you moving to the right? Doesn't matter. You're moving some number to the right. Now, a vertical line is going to be one that goes straight up and down, and that could contain something like this if we list this out. Let's say it goes through the point 1, 7. It could go through the point 1, 1. It could go through the point 1, negative 4. All of those have the same, x value. So it's going to be an x equals equation. When the line goes up and down, the slope on it is undefined. It doesn't have a slope. Slope does not exist. Questions on those? Hopefully this is stuff you did back in Algebra, or Algebra. Now, parallel lines are going to go through and have the same slope, or equal slopes. Looking at what's here, I know that this original equation here in blue is y is equal to 2x minus 5. If I needed to figure out what the equation of the red line is, I can go through and figure it out. It's telling me to use the y value, by the way, of 3. So I'm trying to use this point. This is where the y value, the one that goes up and down, the y value here is 3. It's got a height of 3 at this point. So I want to know what this coordinate is. We know that the y value of it is 3. That's what that piece tells us. Now, how can we figure out the rest of it? Well, the x part of the coordinate would be negative 1, 2, 3, 4, 5. So this goes through the point negative 5, 3. I need that. The other thing I need to know is what the slope is. But before I do this, if the lines are parallel, what does the slope of my line have to be? It's going to have to be the same, which is 2. So I fill that in. I know that the slope is going to have to be 2. And in this case, it's going to be x plus 5 because it's x minus negative 5. Questions on that one? Perpendicular lines have opposite reciprocal slopes. So to start off with, if I know that this graph here, blue one in this case. Yeah. This is y is equal to 5/3 x. How do you figure out what the other line's equation is going to be? Well, if you know it's perpendicular, you know what its slope is going to have to be. Hands up, please, if you can tell me what the slope of that perpendicular line would have to be. I got 1, 2, 3 of us, 4. What do you want to say, please? Terrific. And I can fill in more about that equation. What else can I fill in about this equation? Because right now, that's not the equation of the red line. You can tell me what the equation of the red line is missing. We got one person.
The y-intercept.
What is the y-intercept?
2.
There you go. Questions on that? All right. Let's go through, please. Go through and get done question 1 right now. There's 3 parts. Go through, please, and get done question 1 right now. If you need to go back and look, go ahead and look. Cassie, what would you get for A? Perfect. So far, so good. Next one up. Now, Erica T., which form would you go through and use in order to give out this equation? Do you need point slope or slope intercept? Which one? I'd go through and use point slope. What would you get when you applied it? Because remember, it's going to be y minus y1 equals m times the quantity x minus x1. What would you go through and plug in? So what's that going to look like when you make the replacement? Here's your x1 and y1, and you know what your slope is. So what's this going to look like? No? What are you swapping out? There's only 3 things we can get rid of. x1 and so now put those values into there. What would you have? equals. There you go. Questions on that one? Now the next one's interesting because some of you will see something. You'll see it differently than the others. Nathan, which one, if you went through and did C, you've got to give a line perpendicular to this one that goes through that point. Which formula would you want to? Point slope, okay? So your point slope formula is y minus y1 is equal to m times the quantity x minus x1. So make your replacement in. What's that going to look like?
Y minus 2 equals negative 1 minus x.
Yeah, we could put a minus here there. It doesn't need to be there. Now, that's not the only way, though, that you could do this. Does anybody see another way that we could do this? We got 2, 3 of you, 4. Zach, what do you say? Why could you go right into y equals mx plus b? This is your y-intercept. So you need to be able to recognize that as you're doing it. So this, what is it, plus 2? These two are equal to each other. It doesn't matter which one you go through and pick. Questions on that? All right. But you have to be able to recognize and apply out those formulas. Next one up, we'll give you a couple minutes head start on question number 2. Those are the points that you're going to be working with. Take a look at 2a, and Luke, what do you need to do in order to give the equation of a line that's parallel to the given one and passes through that point? Because what are you trying to get? What do you need to get from this? Yeah, and what's that going to give you when I solve it for y? So this will be plus 20. Divide everything. Y is equal to 4/5 x. I mean, in terms of the question, what do you need to pull out from that new equation? You're right to get to that point. What do you need to pull out from it? Or what do we use that for? Yeah. You got it in this. We need to take this. The only thing that we're using here is that slope. Now, what would you do to get from this to what your final answer is? Yeah. Now, here's one thing that's going to be different, maybe, from before. If it's a multiple choice question, and they're all in y equals mx plus b form, should you go through, distribute out, and solve for y? Yeah. If it's a free response question like this is how you leave a line in calculus. That's the equation of a line. That's perfectly viable. That's why I get very frustrated when I go through, especially, I think it's your 7th and 8th grade year, but to the lesser extent last year. They're constant, from what I understand, they're constantly making you get things in terms of y equals. You don't need to always be doing it. Maybe the region says so for 10th grade, but we don't need that anymore. If it's a multiple choice, you need to know equivalence. But this is a perfectly viable way to leave your answer. Now for question B, this one is a little bit awkward. So if you get stuck, I always advise you, like it said back in the beginning, if we're referencing you doing something out visual, that's something you need to draw it all the time. Because it's amazing how quickly you'll get unstuck. It's perpendicular to the x-axis, which means it meets it at a 90-degree angle, passes through the point 1, -4. So here's my mini Cartesian plane. I'm going to go through, it's got to go through 1, -4. So that means I go over 1 and down 4. That's going to be right here. The point is 1, -4. The line that I'm going to give is perpendicular to the x-axis. So, Alex M., does that mean that the line is going to go up or up and down or side to side? No. If it's perpendicular to the x-axis, it's going to have to go up and down. Now, here's my equation. Hands up, please, if you can tell me what that's the graph of the equation. What is the actual equation itself going to be? We got 2 people, 3, 4.
X equals 1.
Terrific. Terrific. Everywhere along that graph, x is equal to 1. Now, C is a little bit awkward. We know it passes through those 2 points. So, looking at what's there, what would we go through and say, Talia, what's missing from this that we need to have? Slope. Are we given enough information to find the slope? What's the formula for slope? Do you remember? There you go. So we're going to put a delta y over a delta x, change in y, over the change in x. So when I list this out, my numerator, well, you tell me. John Paul, what's the numerator of this going to be?
2 3.
All over? What would I write out? What are the two? What would I have down there? Why is it +1? There you go. Subtracting a negative is the same as adding. So from here, I would go through and get that the slope is going to work out to be -5 over 6. By the way, just as a generalization, you all tend to be good at this, but it doesn't matter which half of the fraction is negative. If the numerator and the denominator are negative, it's positive. If there's a negative in the denominator, just make it rise up to the numerator. So we're not looking at negatives in the denominator. From here, we need to get the equation of the line still. And Ben D, which formula would we go through and use? What's that? So what's that? What's the base formula we're going to be plugging into? No?
Y minus
Good. Equals? Terrific. Now let's make our substitution in. And Noah, what would you go through and get when you did the plug-in?
Y plus 2
Okay?
equals -5 over 6 times x minus 5.
Careful. I'm going to say right now, based off of what you told me, that's what I would write.
Oh, wait, in parentheses.
Now, so we get to that point. Is there another line, by the way, that would be acceptable? Hands up, please, and give me another one that would work.
I minus 3 equals -5 over 6 times parentheses x plus 1.
Either one of those works. They all go through the same points. Questions on that? All right, go through and answer out 3 right now. Taking a look at what's there, this person is selling hats. Cost them $5 to make each one. The profit is modeled by that equation. Based off of what's given, Christina W., what does the X represent? There you go. What would the 50 indicate? Hands up, please, if you can tell me what you think that 50 is going to indicate. 1 second. Yeah, we're going to call it this. Yeah, we're going to call it an initial cost. You could call it a fixed cost. You might want to call it, you put it in good context of the problem. It could also be, you could say it has nothing to do with any form of cost, but you could say that it's the entry fee. So in order for a business to go through and make money, not only, let's say you opened up, what was the new one? What's the one that opened up right next to Dairy Queen? Taco Bell, okay. So let's say we just opened up Taco Bell. If I'm trying to go through and generate a profit, we have to figure out how much to charge people for the food. Now luckily Taco Bell food is made from garbage, so the cost is very, very minimal. It's not, I'm pretty sure it's mostly not garbage, but I'm not 100%. But anyway. So, you have the cost. If I'm trying to make money, the cost of that taco, you have to figure out what it's going to be. So, what goes into that? You're paying for the food. Hands up, please, and tell me something else that you have to include in the cost in order for you to make enough money to stay in business. What?
Employee making it.
Yeah, you got to pay the person to make it. Most people aren't doing that for free there. Who can tell me what else you probably need to pay for? Yeah. The rent. What else? Electricity, that's probably good. Isn't that what they melt the cheese? I think that's electricity. Yes?
Like trays they put them on.
There you go. And then you got the wrapper. You've got the, I'm sure that they probably have some sort of like touch or screen on the thing that like is color, tells you what your order is going to be. There's 1,000 things you have to go through and factor into the cost. So is it different? And by the way, in addition to all that, you have to pay all these different taxes. And can you just randomly start building Taco Bells wherever you want to? What do you have to apply for? A building permit. Is that free or does that cost money? Costs a lot of money. And then, by the way, if you're running a Taco Bell, a Kentucky Fried Chicken, what's the one is it Dairy Queen is next to it? All of those places, in order to put that logo on your store, you have to pay what's called a franchise fee, which means McDonald's makes $1 million every single year for every restaurant that's open, just so you can put a McDonald's on. That's how much money they have to go through and make. So is there a lot of money required? That's why I sit there and go, let's say this. This is my favorite one. There's like a McChicken sandwich, right? And I was in an event, and there were a bunch of boys, and we stopped at McDonald's, and this one boy ordered 7 McChicken sandwiches, right? And I go, how can you eat that? And he goes, they're only $1. And he had this smile on his face. And I got nervous for a minute. Because they only cost $1. Right? Now I want you to think about that for just a second. That means that they're generating a profit from the time the chicken hatches to it getting served to you on a plate. Meaning, not only are you paying for the roof over that McDonald's, the bun, the lettuce, I'm sure something that may be mayonnaise on top of it. And then on top of that, there's a wrapper. There's an employee and a computer system that you're paying for. There's plumbing and bathrooms that maybe work. And then on top of that, you're paying for the chicken to be born and the food for the chicken. And then somehow making the chicken into a patty. I really don't want to know how that happens. And then they put breading on it, so there's bread involved, which means there's grain coming in. All of that costs $1. That's what makes me nervous. That's why I take my godson out for lunch once in a while. And he'll sit there and he'll like get the kids value it. And the like chicken nuggets, which I don't know if that's a natural thing. I've never seen a nugget on a chicken. But you sit there and you go, the chicken nuggets, they were like 99 cents. I'm like, let's just pay for the big chicken sandwich. I'll cut it up for you because sometimes you can get like a chicken breast that looks like an actual piece of food you could get at home. But that's why, and if you're going into any form of economics, that's what you need to be thinking about. And you have to think sort of bigger picture. Now, here's another one. How many hats must this person sell in order to make a profit? How can we go through and figure out what we would have to do for that? We're not going to have many people opening businesses for that one. No. We need to find out what our break-even point is. So the Algebra way to do this, remember, this is your profit. Now, in order to make money, let's finish this inequality. Do I want, this is a light one, and this is really tough. If I've got a business, do I want my profit to be greater than 0, or do I want it to be less than 0? If I want a business, this is not too tough. If I'm running a business, do I want my profit to be bigger than 0 or less than 0? What do you want to say? We want it to be bigger than 0. So instead of profit, what algebraic expression represents the profit? Well, it's 7x minus 50. Now we're going to solve that out. And the one thing that concerns, and it's, again, it's not judgmental in the least, one thing that you all have to get used to doing, there's very few times where like a guess and check method is going to be viable at all. And I hate that they show you that. I'm assuming that you were showed it at some point before you got to me. We will do everything we can to undo guessing and checking. It's very much a last ditch, nothing else is working, and I'm feeling very nervous, and I may cry. If you're at that point, then maybe guess and check is it. But other than that, we need actual algebra. Now, over here, we bring the 50 over, so you've got 7x is greater than 50. I'm going to divide both sides by 7, and I get x is greater than 57. Now, this is the part that I love, because you go into your calculator and say, all right, well, they need to sell more than 57ths of a hat. Raise your hand here if you've ever seen 57ths of anything. I don't know if 57ths even exist. What you have to do is put it in context. How many hats do they need to sell in order to make a profit? Hands up, please, if you can answer that question. We've got 3, 4 of you, 5. John Paul, what you said?
8.
There you go. If they sell less than 7, well, 7 doesn't work, by the way, either. And I know that because 57 is 7 and 1/50th, because 49, 7 times 7 is 49. Now, another time that this comes up, so you have to put it in context, because then you have some people say they have to sell 50 over 7 hats. This came up on a Regents exam once, and they're like, there's a certain number of deer in a field, and it's modeled by this equation, and it grows over time, how many are in a year, and they plug in a year, and you get a number of deer. But the part that was frustrating was, it said you got like 40.21 deer, okay? Who here has ever hunted? So one person that did. All right, well, and did you hunt deer? Okay. Now, you've probably seen in your lifetime, does it say you've seen 40 deer between hunting and driving? Okay. Have you ever seen 0.21 of a deer floating around? No. I haven't either. And then it gets really awkward too, because how do you make 0.21 of a deer? You take like do you see like one arm jumping around in a field? Or did they take it from the side and sort of take a slice of it like on a deli tray? And like, so there's like a sliver, 0.21 slivers of a deer? Or do they go from the bottom up? Or maybe from the top down. That flies up to that 0.21 of the deal. Maybe that's where they get chicken nuggets. It's from 0.21 deers or 0.21 chickens. Who knows? Now, take a look, please. Answer our question 4 right now. What would we list out? Alex, what would you list out for the A part of this question? Y equals what? What did you say?
30x.
Keep going. There you go. The 30 is the hourly rate. The 50 is the fixed cost to get it in. So Alex V, what would you do to answer out the second part of this?
I plugged in 125 for Y.
There you go. And did you solve it out?
It did.
And what did you get?
It came out to me in 2.5 hours. I rounded it to 3.
Now, can 2.5 hours exist?
I rounded it to
Yes, some of you will argue that this class feels like it takes 2.5 hours. That's a viable answer. We'll tell you sometimes when it is and when it. We're talking about like a living organism. Like let's say you have like 14.3 friends. That would round down. Okay. Maybe they're just a really short person. Take a look at 5. You've got a mug with that much coffee in it. 2 ounces weighs that much. The same mug with 6 ounces weighs that much. We need to go through and write a linear function that expresses the weight of this as a function of the fluid ounces in the cup. This is something that you would use, and this method is useful if you go through and you don't know, or if you can't empty out a container entirely. So let's look at what we have here. In order to give out the equation of a line modeling this, who can tell me what I need to find first? Because we don't have enough to answer that out. Yep. We need to find what your rate of change is, or slope. So I go through and say, well, m is going to be equal to the change in y over the change in x. And if we do that, we would have the change in y, I picked the higher point, 1.4 minus 0.6, all over 6 minus 2. Go into your calculators, please. Hands up when you can tell me what that's going to be. Control division to start off. Type it in, you can give me the decimal or the fraction, it doesn't matter which one. But you got to be able to tell me what they are. Hands up, please, when you can. What's that? 0.2 is correct. So if I'm going to give a linear model of this, it's going to be y is equal to, y, we've got to use the point. Let's use the 0.6. Y minus 0.6 is going to be equal to 0.2 times x minus 2. Could we have used the other point and gotten an equivalent answer? Sure. The next part, find the weight of the empty mug. What would I need to fill in to find the weight of the mug when there's no fluid in it? How can I find the weight of the mug when there's no fluid in it? We got one person, really? No takers at all? What do you want to do? There you go. And we'd solve for y. Y minus 0.6 is equal to 0.2 times 0 minus 2. I'll tell you when you go through and do this out, we're not going to finish. This is going to be y is equal to 0.2. That's the value of it. We got one more to go through and do. Which one is going to be, which one out of that group, I think it's only one. Which ones, excuse me, are going to be linear? Take a look at the table. Which ones are linear? D is going to be linear. Who can tell me what else is going to be linear? Nope, because we're not going up by a constant amount. A. This is going to be a constant function. This would be y equals 6. Now, your homework tonight, again, is from that packet. I'll post it on Google Classroom for you to go through. If you want a bigger copy, separate paper with a dash. And by the way, let's make sure we print in a way that a very old person, like myself, will be able to read it when we're doing it. Okay? Have a good rest of your day.
Oh, what's up with Math Excel?
Yeah, that your Math Excel, guys, is due by the end of the day on Wednesday. So make sure you log. Who here has gotten it done? How long did it take? Like maybe 15 minutes? Okay, terrific. Terrific. Have a great rest of your day. Make sure your calculators go back in the right spot. Make sure your calculator's going back in the right spot. If it's not, make it so.